Chapter 1.4, Continuity and One-Sided Limits, Day 5. Today we're going to kind of clean up and put together the final pieces of piecewise functions and the intermediate value theorem. First off, we need to discuss the discontinuities of trig functions. Now, if you remember the graph of sine and cosine, you should remember that for sine and cosine, they are continuous on all real numbers. So when we're looking for discontinuities for sine and cosine, there are none. Now for tangent, cotangent, secant, and cosecant, there are certain discontinuities because they're relations of sine and cosine. Where if you get 0 as a sine, you can't have cosecant continuous. Those discontinuities are for tangent at pi over 2 and then every cycle of pi k back after that. For cotangent, the discontinuities are at pi k, where k is any integer. Secant is pi over 2 plus pi k, because cosine is 0 at pi over 2. And for cosecant, the discontinuities are at pi k. You just need to know this chart. This is from pre-calc, where this stuff does not work out. It's undefined. So using that, where is this function discontinuous? Well, because it's cosine, there's no discontinuities. So this function is continuous. F of x is continuous on all real numbers. We'll say from negative infinity to infinity. Make sure you use an open bracket, which means you don't actually get to the number because you can't actually get to infinity. All right, f of x equals tangent of pi x over 2. Well, if you remember tangent is discontinuous at pi over 2 and then every half circle thereafter. So this function is discontinuous at pi over 2 plus every half circle thereafter, except what's inside is more than just x. So pi over 2x is discontinuous at every pi over 2 plus pi k. And what we want to do is we want to find out the values in terms of x instead of pi over 2. So let's multiply both sides by 2 over pi. And as we distribute, the left side, we just cancel out. The right side will distribute. Pi over 2 times 2 over pi is 1, plus 2 pi times pi, the pi's cancel. So this function is discontinuous at x equals 1 and then every 2 after there. So that's 1, 3, 5, 7, and so on. And every 2 before that. So negative 1, negative 3, negative 5. And we're just describing a formula that lets us know where it's not continuous. All right? Find values of a and b to make these functions continuous. Now remember the 3 points of where a function is continuous, or the 3 qualifications. First qualification, f of a is defined. The second point, the limit of the function as it approaches a exists. And the third point of continuation is that the limit and the function are equal. As long as those 3 things happen, the function is continuous at that point. So let's look at this first example. Find values of a. So find a value for a such that f of x is continuous. So first off, from the left and the right, our limit must be the same. We can see that the limit as x approaches -1 from the negative side, according to this piecewise function, from the negative side, we got 3 times -1 squared is 3, minus 7 is -4. So that means the limit from the right side has to also be -4, which means that -4 equals a times -1 plus 4, and we'll solve for a. Add 4 to or subtract 4 from both sides. A equals 8, and our last qualification, f of -1 needs to equal -4. So if we take this in as 8x plus 4, we stick -1 in and it works. So a equals -1. All right. And finally, an example of the intermediate value theorem. Verify that the intermediate value theorem applies to the indicated interval and find the value of c guaranteed by the theorem. So first off, is this continuous on the interval from 0 to 3? We need to look at that. Because it's a polynomial, that means there's no division. It's continuous on all real numbers. So it's certainly continuous from 0 to 3. Now we need to look at each endpoint. If they surround 0, we know that 0 exists in this interval. So first we'll find f of 0. That equals 8. Plug 0 in. We'll find f of 3. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is -9. -9 plus 8 is -1. And we can see that we surrounded 0. We're a little bit below and a little bit above. So there is a 0 between 0 and 3. And then to find it, we'll take our function and we'll set it equal to 0. We know it exists, so we know we can find it. Use the myriad of ways you've used to solve a quadratic to figure it out. You can factor, you can complete the square, you can use the quadratic formula. This one, as I look at it, I'm going to try factoring first, because when factoring works, it's always quicker and easier. X minus 4, x minus 2, multiply to positive 8, add to -6. So we can see our values of zeros are at 4 and at 2. Which one falls in our interval between 0 and 3? X equals 2. So the value of c guaranteed by this theorem is x equals 2. Okay? So that wraps up chapter 1.4 on continuity and one-sided limits. Remember the 3 points for continuity, and remember the intermediate value theorem. Those are the big main topics, as well as left and right-handed limits.